So in this video lecture, we will discuss various input and output functions provided in the C programming language. So the outline of the lecture is that first we will discuss input functions and then we will discuss various output functions. So how the input and output is managed in C programming language. Every C program considers input and output as moving the data into or out of the program in the form of a stream of data. That is, if the programmer wants to input something, that input will comes from a stream of input, from an input stream. Okay, and if you want to output something, okay, that output will be seen as that data is moving in the form of a stream out of the program, okay, to some output device. Okay, so for input and output there must be a stream, and that stream can be input stream or the output stream, and that stream is accessed using a structure which is called file. So file is written in capital, and this is not a data file, this is a structure. Okay, and this structure is used to access input or output stream. Okay, so a stream can be associated with an input device, or it can be associated with some output device, or it can be associated with some file. Okay, that is data from either some input device or a file can be taken as input, and data can be written to some output device or to some file. Okay, so file can be as an input device or the output device. So luckily three streams are always available for a C program. Okay, std in, std out, std error. That is, if you want to perform some input or output operation, you must have input stream or the output stream. Okay, every C program always has three default streams available to it: std in, std out, and std error. Std in is the standard input, so this is for the input stream, and std out is for a standard output, so this is for the output stream, and std error is for standard error. Okay, and this is for the storing, this is for accessing the standard error file. Okay, so so these three streams are available by default for every C program. Okay, and more streams can be created using the file structure. Okay, so for example, you have two monitors, so one is your default monitor, so the std out stream is associated with your default monitor, and one more output stream can be created for your second monitor using the file structure. Okay, so these three standard streams are always available, more can be created using the file structure. Okay, now there are some input and output functions which works for standard input and output streams. Okay, so the input function getChar, getS, and scanf. These three input functions works with a standard input stream std in, and the three output function putChar, putS, and printf. These works with standard output stream std out. Okay, so while using these functions, there is no need to specify the stream name. Okay, and for other functions you must also specify the name of the stream. Okay, so let's discuss them one by one. First, output functions. So the simplest output function is putChar. Okay, it requires one arguments, one parameter is required for putChar. So this function provides for printing exactly one character to the screen. Okay, why screen? Because screen is by default associated with the std out output stream. Okay, so putChar basically use standard output stream std out, and std out is usually associated with the monitor screen, your default monitor screen. Okay, so example, say character ch, you declare the character ch, then you input a character from keyboard using the get character. We will discuss this function later, and then you print that character ch. using this statement putchar ch. So the value of this character variable ch will be displayed on the monitor. Okay, because putchar works with std out, and std out is associated with the monitor, your default monitor screen. Now another output function putS. PutS provides for printing one line of characters to the screen. Okay, the syntax is putS str. Okay, here str is a character array. Okay, a number of characters can be stored in the str. Okay, so get us input one line of characters, and that str is displayed on the monitor screen using putS. Okay, again here you can see that no stream is specified because putS works with the default output stream std out, which is associated usually with the monitor screen. Now formatted output, that is putS and putchar provides unformatted output, and printf is for formatted output. Okay, so this function provides for formatted output to the screen. The syntax is like this. Printf within small brackets, you first specify format within the double quotes. Okay, and then after the comma, you write a list of variables. Okay, then bracket close, semicolon. Okay, so this is the syntax of a standard printf function. The format includes a listing of data types or the variables to be output, and optionally some text and control characters, right? So for example, here you can see in this code snippet you have two variables, floating point a and integer b. First you read them, okay, and then after reading them we are going to print their values. Okay, so printf works with the standard output monitor screen, so the values of a and b variables will be printed on the monitor screen. So what is the syntax? So within small bracket you write uh, first the format is written within the double quotes. Okay, so the format may contain some text. So here you can see you entered and these are the text. Okay, and it includes a listing of data types. Okay, so we have to print a floating point value and an integer. So percentage h is for printing the floating point number, floating point variable, and percentage d is for printing the integer variable, right? And format may also include some control characters. So here backslash n, that is the new line character, is a control character which inserts a new line. That is, the line will change after printing the values of a and b variables. Okay, and then after the format we put a comma, and then we put a list of variables which are going to be printed. Okay, so here you can see that this list, the order of variables in this list must be same as the order of these specifiers, percentage f and percentage d. So percentage f is for a floating point. Okay, so our floating point variable is a, so we first write a and then we write b because percentage d comes after percentage f. Okay, so for a different data type variable, we have a different specifier. Okay, so this is the list of the format conversion specifier for each data type. So D is used to display an integer. Okay, L is used to display a long variable. E is displays a floating point value in exponential notation. F displays a floating point value. Okay, a variable of floating data type. G displays a number either in E or F. That is, if you are not sure that which is in which format you are to print, then you can use G. So that variable will be printed in either in the floating point value or in the that floating point value will be printed in exponential notation. Okay. C is used to display a single character. Okay, and if you are to display a string of characters, or then you will use S. Okay, so these are the format conversion specifier. Okay, now output functions for any stream. Okay, so now these output functions put C, F put C, F put S, F printf. These works for any stream. Okay, the earlier three, that is put char, put S, and printf. These works only with the standard output stream. Okay, they print on the monitor, your default monitor screen. Okay, but these output function put C, F put C, F put S, and F printf. These works with any stream. So you must also specify the address of that stream, the pointer of that stream using the file structure. Okay, so here this is an example of the uses of put C. Okay, so character ch character is declared. Okay, its value is input from the keyboard. Okay, and here you see the use of put C. Put C character cs, then you write the output stream std out. Okay, so output with a screen. So this statement put C ch std out will write the value of ch variable on the standard output, the stream associated with the std out. That is your default monitor screen. If you want to print the value of ch on some other output device, say some file, some output file, then this will be the statement put c ch within bracket ch comma out file ptr. Okay, so this is the stream for some output file. So now this statement will write the value of ch on the output file associated with this output file ptr, right? So for all these functions, put c, f put c, f put s, f printf, you must specify the stream also, the output stream. Okay, now some input functions. The simplest input function is getChar. The getChar function is for input exactly one character from the keyboard. Keyboard is your default input device, so it is associated with the stdn. Okay, so here you can see in this example, get character simply reads a character from the keyboard. There is no need to specify the input stream over here. Okay, because that it works with the default input stream stdin, and stdin is usually associated with the keyboard. Getters. Okay, so getters functions reads a line from the standard input and stores the value of that line in the specified buffer. Okay, that buffer is a character array. Okay, so example, so here first you declare a character array str. Okay, and in the str you have to store the input line. So how to read that input line? Using this statement, get is str. So there is no need to specify the input stream. Okay, because it is associated with the default input device, keyboard. So whatever you read from the keyboard, okay, so that is all the characters read from the keyboard will be stored in the str. Okay, and how many characters will be stored in the str? You keep inputting the characters from the keyboard until you hit the enter. Okay, that is your new line, right? So all the characters until you hit the new line characters will be read and stored in the str character string. Scanner function provides formatted input, and the syntax is like this: scanf within small bracket, we write the format within the double quotes, then we put a comma, and then we put the address of variables. Okay, here ampersand is the address of the operator. So address of variable 1, then address of variable 2, and so on. Okay, so format is a listing of data types of the variables to be input, and ampersand in front of each variable name tells the system where to store the value that is input. That is, it specifies the address of the variable. Okay, so example is we have two variables. One is a of floating point type, and another is b of type int. So how, see how these two variables are input. Okay, so this is the format string. Okay, so first we input the a. So a type is float, so we use f for the float. So in the format string we write percentage f. Then we input b. The type of b is int. So for int we use d. So percentage d. Okay, see there is no comma between percentage f and percentage d. Okay, and after the format string we put a comma, and then we write the addresses of the variables in the same order as the order of their format specifier. Okay, so in the format string we first write percentage f. Okay, so here we write a variable first because it is the floating point type, right? So this is how the scanf function is used. Okay, so these functions are for any stream: getC, fgetC, fgets, and fscanf. Okay, so these four functions can be used with any stream. They can be used with standard input, and they can also be used with some other input stream. Okay, but you must specify the address of that stream, the pointer of that stream. Okay, so see this example of how getC is used. Okay, so character ch. Okay, getC standard in. So this getC function will take input from the keyboard. Keyboard is your standard input device, and that value will be stored in the character ch. Okay, getC file ptr. Okay, now this getC function will read from uh, the stream associated with the file ptr, and that character will be stored in the character ch.